Hi, this is Dr. Jabali, and we're going to do a video on multiple choice focusing just on topic 1.5. So let's get ahead of the game. Remember to always read the question twice in the test, as well as the four options A, B, C, D. And remember, IB is very picky. Sometimes it's easy to cancel three and find the answer, but there are many times they will have two answers that are very close to each other. Think of the one that is more specific and detailed, that will be the one. So we're going to talk about 1.5, and one of the most common topics in 1.5 is about endosymbiotic theory. So the question says, which statement is an evidence of endosymbiotic theory? So I'm going to refresh a little bit of what endosymbiotic theory is, because some questions ahead we'll talk this subject again. So if you remember, the evidence of this is basically that, well, the assumption, the theory was that back in the old days, there was a prokaryotic, right? And that prokaryotic eventually will turn into an eukaryotic, in which the eukaryotic eventually will have its nucleus, right? Now, these prokaryotics basically said that with time, they do provide a nucleus. Well, fine. So we get the nucleus going on from a pro to an eu. The next thing is, how do we get the other stuff, like the organelles like mitochondria, and I don't know if it's a plant cell, we have basically the chloroplast. Basically, they're saying that back in the old days, that they were saying that the chloroplast right here, as well as the mitochondria, these two used to be bacteria. But because of the harsh conditions on Earth, basically these two were engulfed by the cell. And when they were engulfed by the cell, that means they were eaten, they became an eukaryotic. So that's the assumption, is that, again, mitochondria and chloroplasts were eaten by the prokaryotics and then they become an eukaryotic. Now, why are these assumptions? Why would they come up with such thing? The reason why is because they look at the structure of both bacteria, mitochondria, as well as the chloroplast, and they compare this to a bacteria. And they saw that some things are in common. First, this says that these two, between the three, what do they have in common? They have a double membrane, right? If you remember, mitochondria has an inner outer membrane, chloroplast has an inner outer membrane. Bacteria also, if you notice, bacteria has a cell wall that is made of an inner and outer membrane, right? And it has a plasma membrane. So it does, both of them, all of the three have it. Another thing is that mitochondria, chloroplast, they all have DNA. And guess what? Bacteria also has its own DNA. Third, mitochondria, chloroplast, as well as bacteria, they all have ribosomes. And the size of the ribosome is 70S, even for the mitochondria and chloroplast, which guess what? Bacteria also has it. Also, we use antibiotics to kill bacteria. Antibiotic, I can't write the word antibiotic. So you kill bacteria, right? Well, guess what? If you use antibiotic, you can also kill mitochondria as well as chloroplast. These are just of so many reasons that it goes. And there's a fifth one, which, believe it or not, bacteria can do cell division by binary fission, right? Binary fission. That's its cell division. Well, guess what? Mitochondria as well as chloroplast, they both can go through cell division too. And what? Through binary fission. So this is just a recap of the reason why we think that back in the old days, mitochondria and chloroplast used to be bacteria that were engulfed by a cell and then it became eukaryotic. So now we're looking at the four options here. We have A, says chloroplasts contain 70S ribosome. That's an evidence. B, protein synthesis occurs in the cytoplasm. That's not true, because this happens, yes, it does or happens in the cytoplasm of the bacteria, right? But here, the protein synthesis, it actually happens in the ribosomes. And usually the ribosomes will be inside the mitochondria and chloroplast. And the cytoplasm is not inside of the mitochondria, and the cytoplasm is not inside the chloroplast. Tricky word, very tricky. The next one, it says that organic molecules can be synthesized abiotically. Well, this has nothing to do with this topic. This topic, it's about how mitochondria and chloroplasts eventually became part of a cell and then becoming eukaryotic. It has nothing to do with organic molecule. Organic molecules is like protein, carbs, and lipids. This has nothing to do with building this endosymbiotic theory, which if you look from the word endo, it means going in, and symbiotic means a relationship. So a relationship basically says is that the mitochondria and chloroplast said to the cell, hey dude, let's join our forces in order to handle these harsh conditions of the earth around us. So both mitochondria and chloroplast got into the cell and became eukaryotic just to survive the surroundings. It has nothing to do with producing proteins and carbs, stuff like that. And the last, RNA is self-replicating. RNA is not about self-replicating because that's not what it has. It's DNA. See, mitochondria and chloroplasts, they have DNA. So does the bacteria. Bacteria could have RNA, but it's very rare. So it's not about RNA. So you kind of already have C and D out of the way. So what do we have left here is we actually have two options. This one, but this one we said that it does not happen in cytoplasm, although it's tricky. So we know that chloroplast has a 70S ribosome, and which is true. Chloroplast is one of the evidence because look, it has the 70S ribosome against bacteria. So the answer is A. So know the 5 examples of showing of evidence how this two, mitochondria and chloroplast, used to be bacteria and they got into a cell and became an eukaryotic. Next, how do both mitochondria, right here, as well as chloroplast, provide evidence for antibiotics? So it's just like I just talked about before. You know the 5 evidence. I'm not going to repeat here. So let's look at the options. We have first one. They have a double membrane. Yes, that was one of the evidence that I showed you. They have an ADS? No, they do not have ADS ribosome. Because again, prokaryotics, what do they have? They have a 70S. The next one, they contain the same DNA in the nucleus? No, they don't. There is a different bacteria and different chloroplasts will have different DNA than the mitochondria. So no, it's definitely not this one too. And then the last one, they exist together in eukaryotic cells for their mutual benefit. That does not provide evidence. And what I mean by this is just because they exist in eukaryotic cells, they have mutual benefit. That's not true. Like animals, we don't have chloroplasts, and they still are eukaryotics. I mean, in plants, it's okay. Yes, chloroplasts, mitochondria, they help each other. But when it comes to animals, which is an eukaryotic, you don't need the chloroplast in order to be the evidence. So even though this is very a good answer, but it just works with plants. It does not work with animal, right? Because we know that plants and animal, both of them are part of the eukaryotic. So this is not so bad, but this is more specific. So this will be the right answer. A is the right answer, my friend. Moving on, let's talk about the Pasteur experiment. So in his experiments, what he was trying to prove, that spontaneous generation does not work, right? So he demonstrated if the broth was boiled to kill all the organism, then it was kept in a swan neck flask, preventing the entry of organism, no organism will grow, right? So if there's no bacteria there, everything is dead, then nothing can pop out of it because everything is dead. Now, if the swan neck was broken, then of course mold will start to grow. What does that mean in a drawing? So let's say you have a flask here and you have inside of it made chicken broth right here. This is chicken broth. And if you keep it open, you will have bacteria coming here and they start to grow, right? Microbes. Now, where did these guys come from? They come from the air. They just landed there and then they start to grow. What he did was he took this broth, right? And he heated up. And when he heated up with fire here, he basically sterilized it. So what does that mean? He cleaned it up. So there was no bacteria in there. If you kept it that way, most likely you're going to get bacteria again because the bacteria goes in. But what he did was he sterilized it at the same time he locked it. Now, when he sterilized, that means he killed any bacteria that is inside. So here everything is dead. And because it's dead, nothing show up afterwards. Nothing. There was nothing else because dead cells, you cannot make new cells from dead cells. But when he decided to break this guy, what happened? voila, new bacteria came in. Why is that? Because these cells of bacteria landed here. So basically proved that for a new cell to come up, it came from a previous cell that was living and not dead. So that was a very quick generalized explanation of Pasteur's experiment. So what did this statement suggest? Here are the four options. The first one, it says that mold evolved from endosymbiosis. Endosymbiosis has nothing to do, this has to do with mitochondria and chloroplast. Next, B, oxygen is required for anaerobic respiration. The word anaerobic here, it means no oxygen, right? An means no, anaerobic means oxygen. So this already contradicts. So these two is already out of the way. Next, the cell can only be formed by division of a pre-existing cell. See, it's proving that this cell came from a previous cell that was leaving. This is more likely to be the answer, but check D. Nutrients are a requirement for mold growth. If you want to make new molds, you have to have a cell, not just nutrients in this case. So it has nothing to do with Pasteur experiment. So the right answer here is C. See, cells can come from pre-existing cells. That's the point. Pasteur wants to say, hey, a new cell can only come from a previous cell. Now, next question. Which organelle here provides evidence of eukaryotic cells originated from large prokaryotes engulfing small living ones, right? So we're basically saying is what kind of cell what kind of organelle did they engulf? So you have here a large cell and somehow they engulf. The word engulf, for people who don't know, engulf means like take in. That means this thing is getting inside, that's been engulfed. So if you remember the story about the endosymbiosis, we engulfed two things. We engulfed a chloroplast, right? And we engulfed the mitochondria. So it's obvious that we can even cancel all of these guys. Who did he actually engulf in this situation? The one that engulfed was a chloroplast. So the answer is A. This is, again, if you know the story of endosymbiosis theory, you easily can spot the answer. Now we're back to Pasteur experiment again. Remember, it was all about proving that cells come from a previous living cells. So he has the flask, he has the broth, which is a chicken broth, and he basically, looking at this story here, they did a copy of his experiment and they put the broth in certain flask. So there's 4 different options here. The first one, it was not boiled and not sealed. The second one, he did boiled, but he did not seal. The third one, he boiled and then he sealed. The last one, he boiled but not sealed. So these 4 scenarios, all of these scenarios trying to say is, hey, you cannot make new cells from dead cells. You can only make new cells from previous living cells. So these are 4 different scenarios. Now here says, what result will be expected with no spontaneous generation of life? So what results will be expected with no spontaneous generation of life? That means you're not going to be able to prove it, that it just pops out of the way. So we have 4 options here. Decomposition means the breakdown. So the breakdown of the broth by microbes. So it's basically saying that we have here microbes come in here, right, and start eating the chicken. Or should I say the broth here, right? So that's what decomposition means of the broth by the microbes. So here it says that the decomposition of broth from microbes occurred only in flax W. Let's go back to this and back to the scenario. Like here, you did not boil and you did not seal. If you did not boil, that means they probably already had bacteria out here and it just grew it eventually. So there was microbes there. So the A, for sure, it's true. There was microbes eating the broth. The second one, you boiled it. That means you heat it up. So what did you do? You sterilized. So there was no microbes. But because you can see the opening is easy, right? So the microbes in the air just came in, landed, and start growing again. So B is more likely because it says W and X. But let's look at why. Why you boiled it. That means there was no more microbes there. Everything was dead. And then you sealed. Now, when you sealed it, nothing else could come. Look, You see that the line is closed? So that means nothing grew here. Everything was clear, sterilized, dead cells. And because there was dead cells, I cannot draw dots here because microbes did not grow. This one, you boiled it, but you do not seal. But here's the funny thing. These microbes, when they are in the air, they come in, they land here. They land like this, falling down. They cannot just swim up and then go swim down, up and then down. That's why all the microbes will be stuck here and they won't have a way to go all the way up here to get back in. So even here, there was no growth of microbes. So C and D, when it says decomposing the broth of microbes occurred, it did not occur on the Y's and the Z's. It did not happen. It only happened on the first two. So only here you can see that there was a spontaneous generation, and only through these can you prove the other way going. So the answer here, it is B. Now the next question here, it says the image shows a white blood cell seen as a transmission of electron microscope. So this is a white blood cells. When I say white blood cells, we're talking about animal cells. Phagocytic is a name for immune system cells. So don't panic on this. So this is a micrograph. Now the question says, what is the future? Then it means we're talking about trait. That can be found both within this cell as well as a photosynthetic bacterium. So we have to look at this picture right here and see what do we able to see around this guy. So first, photosynthetic bacterium, chloroplast, right? Because of this. Can I see a chloroplast here? No, because what does a chloroplast picture usually looks like? It usually looks like a dome like this, right? A dome like that. And you don't see any of that anywhere in this drawing at all, right? I don't think you can see anything of that. So no, I don't think that's the one. So chloroplast will not be one of it. So it's out. Next, about multiple nuclei. We don't see any multiple nuclei here. Because again, the most important part, you don't even have to see in this picture because again, you gotta say that it's found both in this cell as well as in bacteria. But hello, bacteria is a prokaryotic, and what does the prokaryotic don't have? A nucleus. So this one out of the way. Next, 7S ribosomes or lysosomes. This, even if you don't see in the pictures at all, even though there is ribosomes here, but look at the lysosome. Lysosome, bacteria, if you knew the drawing, it has a cell wall, it has plasma membrane, it has DNA, and then ribosomes. Bacterias never ever have lysosomes. Lysosomes are only found in animal cells. So that cancels. So the only thing left is C. So even if you did not know how to identify in this drawing any of these stuff, you can use this with logic. The only one that you couldn't find in the beginning was the chloroplast. You couldn't know about it, right? Because it can be found in this cell stuff. But here, if it does, it would have looked like this. This is what it looks like. Like it's a half of a partial part of a cell. This is what it looks like, but it doesn't have on this drawing. So this is only the first one that has a hard time talking. But this, you know, bacteria don't have nuclei. This one, you know, bacteria don't have lysosome. So you're just stuck between these two. But now that you know the chloroplast has a way of being drawn, it's not even on this picture. So you're only left with the 7S ribosome, which is C. Now we're going to the last question for 1.5. Which statement provides evidence for symbiosis? By now, I have explained so many times endosymbiosis, you probably already have an idea. So let's look at the 4 options. First, it says early prokaryotics contributed to the large increase in oxygen in the atmosphere. This has nothing to do with building oxygen in the atmosphere. Endosymbiosis has to do with engulfing mitochondria and chloroplast. So A is out. B, eukaryotic mitochondria and chloroplast have their own circular DNA. That's one of the evidence, remember? We're saying that mitochondrial chloroplast used to be a bacteria, and know that bacteria have DNA, and that means they can do their own binary fission. So we believed because mitochondria and chloroplast have DNA, they could have been a bacteria before they were engulfed. So B is more likely to be the answer, but let's check the other ones. certain groups of ancient prokaryotics developed mechanisms to carry out aerobic respiration. Well, that's not true because, again, the mitochondria is the one that has to do it, right? But then the chloroplast does not do aerobic respiration. So what are you talking about the chloroplast in this case? Not really. So this is not a full answer. Okay, this is very brief and generalized. The last one is experiments with Miller and Ure produce simple organomolecules into abiotic addiction. This is talking about the opposite. We're basically saying that we made urea, which is a piss, from abiotic, which basically is just elements. This has nothing to do with endosymbiosis. This is producing urea from inorganic material. So this experiment is not related. So the only option you have here is B, which again, if you go back to endosymbiosis, there's 5 evidence. The first evidence is a double layer. So I'm just going to repeat them to keep you in your mind. Second, they all have DNA. Third, they all have the 70S ribosome. Fourth, they do binary fission. And the last one, I did not forget, double layer, DNA, 70S ribosome, binary fission. They kill with antibiotics. So these are the 5 evidence of endosymbiosis. If it doesn't mention any of these 5, then we're not talking about endosymbiosis. These are the 5 things that you can find in mitochondria and chloroplast. And so we believe that it used to be a bacteria before they were engulfed by the eukaryotic. And that's pretty much for this one. Thank you. Good luck.